Hi, I'm Mary, and welcome to my channel. In this video, we're going to be working with exponents. There's a worksheet that's linked in the discussion box below. So if you'd like to print that out and work along, that'd be great. If not, just follow along on the video. The worksheet, we'll do about half the problems on the video. The other half are there for you, and there are answers at the bottom of the worksheet. So you can take breaks on the video and check in with your skills and see what you need. Okay, so I'm going to share my screen. Okay, so what, we see this notation where we have a base. Here is the base, the variable x. And the exponent is 2. And what that means is we're going to take the factor x 2 times. So we're going to multiply x times x. Okay, x raised to the exponent to the power 3. It's called x cubed, x 3 times. In general, x to the n, we have x times that factor multiplied by itself n times. Okay, 2 special rules we have to keep track of. Anything raised to the 0 power is 1, and then anything raised to the 1 power is itself. Okay, so we're going to take this over to the whiteboard. And we'll work on some of these other problems here from the worksheet. Okay. So 5 raised to the power 2, 5 squared, it means 5, that value, that base, that many times. 5 times 5 is 25. 2 to the power 3 is 2 times 2 times 2, which is 4 times 2 or 8. So 2 cubed is 8. And let's go ahead, write out 3 raised to the power 4. 3 times 3 times 3 times 3. Okay, so that's, I like to think about it. You can actually think about it any way you want. I'm going to, rearrange this. We have that property of multiplication where we're allowed to sort of rearrange things and group them. So 9 times 9, 81. 3 to the 4th power is 81. And 12 to the 0, anything to the 0 is 1, and anything to the 1 power is itself 12. Okay, so just a little bit of practice. We're going to come on over here and think about these rules now. So the first rule is the product rule. Kind of use up some space, and then I'll make small notes for us, so we'll figure it all out. Okay, so the product rule says b to the m times b to the n is equal to b to the m plus n. All right, I want to go ahead and show you an example of that rule. And the one that I like, because sometimes I need to remember it, so I can't always, the memory, but I have a way of working through it, and so that I can figure it out. So if I know this example, x raised to the 3rd power times x raised to the 2nd power. Let's just write that out. The first part is x times x times x. And the second part there is x 2 times. And again, when we multiply, we can multiply all together. So we have x multiplied by itself 5 times. And so we can remember here then that x cubed, if x cubed times x squared, and maybe we have to remember this little path, is x to the fifth, that'll help us remember this rule as well. So the example is just what I wanted to put up here. X cubed times x squared is equal to x to the fifth. So it just gives us a way to kind of use that and remember it. Another product rule is to think about b to the m divided by b to the n and the rule says that's b to the m minus n. Okay, we're going to have an example. Okay, so we're going to look at this second part of the product rule, often referred to as the quotient rule. Okay, but it's really the same. It's a related situation. So the rule says b raised to the power m divided by b raised to the power n is b to the m minus n, numerator power minus denominator. So just want to, again, one of those things that for me, sometimes it's helpful to have an example to run through. So I'm sure I'm remembering what the rule means and how to use it. So here's the example I often use in my head is y to the fifth divided by y cubed. Y to the fifth means y repeated 5 times divided by y cubed. Now, this is a fraction and we can cancel common factors, numerator and denominator. And what we see is there are 3 y's here and 3 y's here that are common and cancel. And we end up with y times y, also known as y squared. So that'll remind us then, y to the fifth over y cubed is y to the 5 minus 3, y squared. Okay. We're going to put that over on our little table there. Okay. So the next rule that we want to look at is the negative exponent rule. And it's a statement that says b to the minus n is equal to 1 over b to the n. So I'll just kind of translate that on the side here. If we have x to the minus 2, okay, then this is equivalent to 1 over x squared. And I'm just going to write the left-hand side as a fraction as well. So you can always use a fraction of 1. Okay, and what's going on here is that if our term crosses the fraction bar, the sign changes. So it's negative upstairs, and then if it goes downstairs or up, right? If it goes from upstairs to downstairs, then the sign changes. There's another expression here, but it also works with this idea of moving from upstairs to downstairs. Okay, so the example I want to look at an example of this. We can look at 1 over z to the minus 5, right? And so we're going to take that z to the minus 5 and bring them upstairs. So whenever you go from upstairs to downstairs, you cross the elevator there, escalator, or however your staircase, it flips the sign. So that becomes z to the fifth, right, over 1. Or maybe you just see that right as z to the fifth. Okay, so I'm just going to put these up on the table now. Okay, so we're going to move on to power rules. And they have 3 different expressions here. So we'll take the first one and explore for a minute. So we want to look at the power rule, b to the m raised to the n power is equal to b to the m times n. But let's go ahead and explore it before we just use it without thinking about it. So I wanted to think about b squared raised to the 3rd power. So what I'm going to do is I'm going to use the idea of the order of operations, and I'm going to look at the outmost piece, this the outmost piece is that cube, that 3rd power. So I want to think about b squared repeating 3 times. Okay, and now let's write each of them out. Each of them has 2 b's, b squared. And now I can kind of put them all together. All right, that's the right number. And as it turns out, it's b to the 6th. There are 6 b's. So we do have an example. B squared raised to the 3rd power is b to the 2 times 3, b to the 6th. Okay, so that helps us to remember that example, that rule. Okay, and so we're going to move on to this second kind of power rule. It says, if we look at a times b and we raise it to the nth power, then that's going to be a to the n times b to the n. All right, so I'm going to kind of explore that. So we have 5x, that whole quantity raised to the 2nd power. We have the answer, but I just kind of want to explore it and show why this rule works. So 5x is multiplied 2 times. Okay, we know that we can rearrange the terms in the multiplication and the product. So I'm going to go ahead and make 2 buckets here. One bucket is going to be for numbers, and the other bucket is going to be for x's. And I see that I have 2 5s, so I'll put them over here in the number bucket. And I'm going to put the x's over here. Okay. So we end up with 2 5s, so 5 squared and 2 x's, x squared. So 5x quantity raised to the 2nd power is 5 squared times x squared. All right, you guys. We're going to go to this next one. This is the last of our rules that I just wanted to talk about. And it says a over b to the nth power, is equal to a to the nth to the n power b divided by b to the n power. And the example I wanted to look at was 2/3, and that whole fraction raised to the 2nd power or squared. All right, and so we get 2/3 times 2/3. And we know how we multiply fractions. We multiply the numerators and we multiply the denominators. Look at that. We notice that that is 2 2s in the numerator, and they're a product of 2 3s in the denominator. So we get 2 squared divided by 3 squared. Okay. All right. So that's it for the examples. Okay, so we're just going to do some of the problems that are on the worksheet. You can pause when you want to and do the other ones and check the answers. At the back of the worksheet, at the end of the worksheet, you have answers. Okay, so the first problem says, parentheses, 3x cubed times in parentheses 4x to the 6th. So we're going to go ahead and rearrange we can remove, well, go ahead and remove your parentheses, right? We could just list everything like that. And now we're going to collect all the numbers in one bucket and all the x's in the other. So this is 3 times 4 in the number bucket, x cubed times x to the 6th in that x bucket. All right. And now we know this looks like that rule that we had talked about before, the product rule. Okay, so the numbers give us a 12, and this is x to the 3 plus 6. So it's 12x to the 9th. Okay. All right, and let's go ahead. We're going to look at number 3. So we're going to, first thing we're going to do is we're going to take care of the exponent order of operations. Okay. So we have 7 times 3x squared. And now we have 4x, that whole quantity raised to the 3rd power. Okay, and this is part of this power rule here. So it says I can take each factor on the inside and raise it to that power. So 4x raised to the 3rd power, I can say is 4 to the 3rd times x to the 3rd. Okay, so we're going to go ahead and find our little buckets here, all the numbers accumulating here. You guys, if you see it all very quickly, that's fine. You don't have to put the buckets, right? But when I'm first starting to do it, it's helpful for sorting through. So we have a 7, a 3, and a 4 to the 3rd power. And then in the x bucket, we have x squared and x cubed. All right. So the hard work is getting the number correct. Okay, and the numbers multiply out to 1,344. And then this bucket with the x's, we have x to the 2 plus 3. So that's 1,344, x raised to the 5th power of 5 to the 5th power. Okay, and number 5, skipping, number 5, 4 to the 0. Let's go ahead. Anything to the 0 power is 1. Okay, so why don't you pause? If you'd like, you can do problems 2 and 4 and 6. Yeah, 6 and 7 as well. Okay, and we'll pick up with number 8 after we take the little break. Okay, so coming back in, we're going to look at problem number 8, which said it asks for 4 raised to the minus 3. Negative exponent rule. That's 1 over 4 raised to the power 3. Okay. Can continue to re-express 4 to the power 3 if you like. That's fine. I'm going to leave it here for today, but that, you should be able to recognize that number in different forms. So number 9, 3 to the minus 3 times 3 to the minus 3 times 3 to the 1. Okay, and so we can use this rule here. That's going to be that version of the product rule, 3 to the minus 3 plus 1, which is 3 to the minus 2. You can also write that as 1 over 3 squared. There's different ways you can get to that answer, or 1 over 9. All right, and number 11, x to the 4th raised to the minus 7 power. Okay, so let's go ahead. Well, you use the exponent, on the outside first, and we're going to take this, we're going to think about it as a fraction. And when x to the 4th raised to the minus 7 power, it's going to go from upstairs to downstairs. That negative sign is going to flip to a positive. So this turns into x to the 4th, rather 1 over x to the 4th raised to the 7th power. Okay, and then that is applying the power rule. We're going to multiply exponent to a power 4 times 7, 1 over 28. 1 over x to the power 28. Okay. So you can pause and we'll come back and wrap up. Do one more problem. We'll do the last problem together. Give those other problems. Okay. Number 15, the last problem on the worksheet. What I'm going to do is I'm going to consider these as this problem as 3 separate problems. We'll separate it. We'll work on the number problem, the number bucket, the X bucket, and the Y bucket. So let's go ahead and separate it a bit. So we get 3 to the minus 7 because we're really good at solving small problems. So when we have big problems, we break it up into small problems that we can think about one little bucket at a time. Okay, so we have the numbers, and here are the X's, and here are the Y's. Okay, so think about this, right? So we can bring the numerator downstairs, and the 7 will go from a negative to a positive. And that way we'll have a positive exponent. There are different ways to express this number. What I'm going to do is I'm going to express it with positive exponents. Okay, and so we get 3 to the minus 4 plus 7. So that number comes out to be 1 over 3 cubed. All right, in the X piece, let's let the minus 5 come up. It'll turn into a 5, and we'll have a positive exponent. So this will be X to the minus 2 plus 5. And so that little bucket is X to the 3rd power over 1. And finally, we look at the Y's. Y to the 3rd power over Y to the 6th. Okay, and so if we bring the 3 down, it'll turn into a minus 3. So we have Y to the 6th minus 3. And that cleans up 1 over Y cubed. Bringing it all together, right? Bringing it all together, we have X cubed in the numerator, and in the denominator, 3 cubed, which is 27. 3 times 3 is 9, times 3 is 27. And in the denominator, Y cubed. Okay, and that's the final problem. Come to the next video. We will do a little more practice with these more complex ones. Okay, I'll see you there.